Good afternoon, physics students. Today we're going to be coming back to a topic we had talked about earlier in the semester, velocity, and we're going to use what we've learned about unit conversions to work with velocity. So, even though we haven't talked about velocity in a little bit, we've been talking about the components that make up velocity, and that's distance and time. So, as a review, velocity is also known as speed with direction, can be thought of as how far you're changing your distance over how far you're changing your time. Remember, these triangles stand for delta. So again, velocity is the change in distance over the change in time. So there's the two most common ways we think about velocity is through units of speed. For example, miles per hour. That's how we measure the speed of a car, for example, on the highway. Or meters per second. So, when we think about miles per hour, miles is the unit of distance on the top, per hour is the unit of time on the bottom, and meters per second, meters is the unit of distance versus second being the unit of time. So, we might use these different types of units in different situations, but sometimes they can be hard to compare to one another directly. And that's where we're going to need our tools for unit conversion. All right, so here's an example of a problem like that. We have two pitchers. They're trying out for the team. One pitcher says he can throw a 30 mile per hour fastball. The other says he can throw a ball at 20 meters per second. But who can actually throw it faster? So to do this, we're going to have to convert one of these into the other so we can make a direct apples to apples comparison. So we're going to convert both of these pitchers, their speeds, into meters per second so we can compare it more directly. So that means to convert miles per hour into meters per second, we're going to have to do two conversions. We're going to convert the miles into meters, and we're going to have to convert the hours into seconds. So step one, we have to identify which conversions we need. So like I just mentioned, for distance, we're going to have to go from miles to meters. And we know that in 1 mile is roughly 1,600 meters. And for the time, we're going to convert seconds or hours into seconds. And we know 1 hour has 3,600 seconds in it. Okay. Step two is we have to convert these conversions or change these conversions into fractions. So remember, there's always two fractions you can make for each conversion. So for the distance conversion, we have 1 mile over 1,600 meters. Or we can write that by flipping the fraction, 1,600 meters over 1 mile. So both of these are acceptable conversion fractions for that distance conversion. Next, for the time, we've got 1 hour over 3,600 seconds. Or you can write that as 3,600 seconds over 1 hour. Both of these, again, are acceptable ways to write this conversion fraction. Okay, now we're done with step two. Step three involves identifying our starting amount and converting it into a fraction. So our starting amount, we're going to convert the miles per hour into meters per second. So I took 30 miles per hour and made it a fraction. So 30 miles, we have the distance on the top, time on the bottom. And remember, to make a number into a fraction, all we have to do is divide it by 1. All right. So in step 4, we're going to choose our conversion fractions. On the left side, we've got our distance fractions options, 1 mile over 1,600 meters or 1,600 meters over 1 mile. So we're trying to change miles into meters. So we have to remember that our conversion fraction should be eliminating our old unit while keeping the new unit. So we need to be eliminating miles, but keeping meters. So to do that, we're going to have to make sure the miles are on opposite sides. So in our starting, miles is on the top, so our conversion fraction needs miles on the bottom. So that looks like our second fraction here. So I'm going to circle that. That's what we're going to need. And then for our time, we've got hours on the bottom. So in our conversion fraction, we need hours on the top so they can cancel out. So that looks like our first fraction here. All right. So now that we've got our two conversion fractions, we can write out our fraction multiplication. So we start off with our starting amount, 30 miles an hour. I'm going to plug in our first conversion fraction, 1,600 meters over 1 mile. And we can see that that fraction successfully crosses out the old units and leaving, let me write that out, leaving our units that we want, 1,600 meters. Okay. Next, we're going to plug in our time conversion. So we've got 1 hour over 3,600 seconds. You can see again, the hours in hours cancel out, leaving just seconds. Great. So now we know our final answer is going to have a conversion of our units of meters per second. So now we just have to multiply across the top and multiply across the bottom to get our answer. So along the top, we've got 30 times 1,600 times 1. And that comes out to, when I do it on my calculator, let me find a calculator that has a battery in it. I'll just do it on my computer here. So 30 times 1,600 times 1, as you can see up here, is 48,000. Okay, so we're going to write 48,000 at the top here. And remember, the units is going to be meters. And then on the bottom, we have 1 times 1 times 3,600. So I know multiplying by 1, it just gets me that number. So 1 times 1 times 3,600 is just 3,600 seconds. So for step 6, all we need to do is now divide 48,000 by 3,600. Leaving us with 13.33 meters per second. So that's our final answer. 13.33 meters per second. Okay, so who actually threw it faster? So based off of this, it's clear that the person, even though 30 miles per hour sounds like it could be faster because it's a larger number, actually the person who's throwing at 20 meters per second has a faster fastball. So we'll go with player 2. Alright, great work. So use this video to follow along in the guided notes, and then you're going to follow the same exact process for your exit ticket question. Good luck.